Alright guys, so on your problem set today, it's going to be asking you to create equivalent fractions using two number lines. So I've kind of already done my two number lines here, just so that I didn't have to spend extra time on the video doing that. But you can see I've got my two number lines here, so you would need to start by just drawing those two number lines. And then you always mark right here a 0 and then at the end a 1. Now, like, so you won't always have 0 and 1. Sometimes you'll be like between 2 and 3 or between 5 and 6 or whatever. But for the purpose of these equivalent fractions, you're always going to have a 0 at the beginning and a 1 at the end. All right? So the first thing you're going to want to do is you're going to want to figure out what you want, how many parts you want your whole thing, how many parts you want it to be split into. So let's say you wanted your fraction to have a 2 as the denominator, and you wanted the whole thing to be split into two parts. Well, to be able to split a number line into two parts, you're just going to need to draw one line right down the middle. So there we can see we've got one part, two parts, and that would be a whole of 2 over 2. So right here, if we were putting our fractions in, this would just be 0. This would be 1 out of 2 of those pieces. And then this would be 2 out of 2 of those pieces, which is the same as 1. You can see that it's like 2 over 2 is the same as 1 because you've got both pieces, which is the whole. Okay? So then, this is where it gets a little bit more tricky, is where you want to create that equivalent fraction, or the equivalent fractions down here. So what we're going to do is we are going to split, instead of splitting it into two pieces, we're going to split it into 4 pieces. So when you're making your equivalent fractions, you always want to just, for now, just double whatever you started with. So you did 2 over 2 on the top. So down here at the bottom, we're going to do 4 over 4. And we're going to make our number line into 4 pieces instead of 2. So we're still going to split it in half, and that's still going to be, you know, the same in the same spot. But then we're also going to do 2 more lines so that now we have our number line split into 1, 2, 3, 4 pieces. So now we are going to go through and label those. So we're going to have, this is going to be just 0 still. This is going to be 1 out of, oop, that was my bad. 1 out of 4. This is going to be 2 out of 4 because we can see we've done 2. There's 1 piece, 2 pieces. This is going to be 3 out of 4. There's our third piece. And then this is going to be 4 out of 4. And there's our fourth piece. Okay, so we've kind of got our 4 pieces. It's split into 4 pieces. So now it's going to ask you, like at the bottom, it's going to ask you to figure out what 2 equivalent fractions from those number lines would be. So we can see, first of all, we've got this one. We've got 1/2, and that would be equivalent to 2/4. And then you could also do 2/2 is equivalent to 4/4. And those would be 2 examples of equivalent fractions for you. Alright, so now I'm going to show you a little bit more of a tricky example here. So on the top here, I'm going to make this top number line, and I'm going to split it into 5 equal pieces. So I'm going to want there to be 5 pieces here. So I'm just going to go ahead and write 5/5 over my 1 because the 5/5 will be my whole. And then I'm going to figure out what the equivalent fractions of that would be down here on the bottom number line. So on the top, I'm going to need to use 4 lines so that I can split that number line into 5 pieces. So I'm going to try to make these as even as possible. Forgive me if they're not perfect, but I'm going to try to do this. There's 1, 2, 3, 4, and see I'm a little off there, so I'm just going to try that one more time. Fifths are a little tricky. I'm going to try this one more time. 1, 2, 3, 4. That's better. So I've got, you can see now I've got 1, 2, 3, 4, 5 pieces. So I used 4 lines and to split my number line into 5 pieces. Okay, so I'm just going to label that real quick. I've got I've got 0. I've got 1/5, 2/5, 3/5, 4/5, and 5/5. So then I'm gonna go down here. And remember, to make my equivalent number line, I just double whatever I started with. So up there, I had 5/5. So down here, I'm going to do 10/10. And I'm gonna split my number line into 10 pieces instead of 5. So I'm gonna have 10/10. And now this is gonna be the tricky part. So the first thing I'm gonna do is I'm just gonna copy down the lines from up here. I'm going to copy down my lines. Okay, and I did the best I could. And now what I'm going to need to do is I'm going to need to split each of those pieces in half again. Because, you know, we had 5 sections up here on top, and we're going to need to have 10 sections down here on the bottom. So that means I'm going to split my 5 sections that I already had in half again to make 10. I hope that makes sense. So I'm just going to split each one in half again. And that way I'm going to end up having 10 sections, hopefully, if I did that correctly. So we've got 0, 1/10, 2/10, 3/10, 4/10. It's hard to write this with a little stylus. I don't have my good stylus. 6/10, 7/10, 8/10, 9/10, and then the one I already wrote, which was 10/10. Sorry, I know that that's not the most clear and beautiful writing for you, but hopefully you can see well enough. So we can see that we've split it into 10 sections down here. So the thing that is a little bit trickier to see on here is that some of these lines down here on the bottom are actually lined up with some of the lines up here on the top. So I'm just going to draw a line from the equivalent fractions on top to the equivalent fractions on the bottom so that you can kind of see. So we can kind of see that certain ones of these fractions on the top actually do line up with certain other fractions on the bottom here. So the reason that is because it's really no different. It's just that we're splitting the number line into more pieces. But some of those marks, some of those places are still the same as we had on the top. So anyway, now that we've kind of got our 2 number lines drawn, we can see which ones are equivalent. So we can see that obviously 1/5 and 2/10 are equivalent right here. So I'm going to say 1/5 equals 2/10. And then we can see that 2/5 is equivalent to 4/10 right there. So 2/5 is equivalent to 4/10. And then you can find some more. 3/5 is equivalent to 6/10. And then 4/5 is equivalent to 8/10. Okay, so the other thing that you can notice is that if you're having a hard time figuring out like how these things line up with each other to find the equivalent fractions, because drawing is really hard, like drawing them well enough to be able to find that can be really tricky, is if you can just draw your top number line, you can actually just multiply the fraction on top times 2 to get an equivalent fraction. So let me show you what I mean. So like if you have 1/5 from your top number line and you multiply the top times 2 and the bottom times 2, that's going to give you your 2/10. Okay, which is what I found by drawing it, but you can just find it by multiplying it times 2. So like if you take any fraction and you multiply the top and the bottom times 2, you're going to find an equivalent fraction. So you can do times 2 times 2, and you can see that 2/5 equals 4/10 right here. And you can do that with any of these. You can just multiply the top and the bottom by 2, and then you can have the equivalent fractions that you need. Alright guys, so the lesson for today is really simple and straightforward. I think you guys are really going to like it. So what we're going to be trying to do here is we are going to be trying to add fractions with like denominators. So what that means is that we are going to work on adding fractions that have the same denominators as each other. So for this problem, we are going to be practicing adding 5/6 plus 2/6. So these squares up here are each going to represent 1/6 piece, okay? So I'm going to write 1/6 on each of these because each of these is going to represent a 1/6 piece. 1/6, 1/6, 1/6, 1/6, 1/6. So as you can see from our problem, we're adding 5/6 plus 2/6, right? So we're going to be adding those amounts together. So all together we can see that we have 1, 2, 3, 4, 5, 6, 7. And so our answer for this one would be 7/6. It's as simple as that. It's as simple as that. So one important thing to remember is that you can only add fractions like this together if they do have the same number on the bottom, if they do have the same denominator. So for example, if this problem, instead of being 5/6 plus 2/6, if it was 5/6 plus 2/8, we wouldn't be able to just add those together the same way. We would have to get something the same on the bottom. We would have to get the same number on the bottom and find a common denominator, which I've gone over some of you guys with that a little bit, but we're not going to worry about that quite yet. So instead, today, what we're going to be focusing on is just adding these fractions that do have the same number on the bottom, okay? Adding these fractions that do have like denominators. All right, so the next one we're going to look at is we are going to look at this number, which is going to be adding fourths together. So we're going to pretend like each one of these boxes is a 1/4 piece, okay? And we're going to be adding together 5/4, which you can see is this piece right here, plus 1/4, which is this piece right here. All right, and we're going to add those two together, and that would simply be, if we put them together, would simply be 6/4. Now, something that you can keep in mind is that, well, we know from the work with number lines that we've been doing that 4/4 would be the same as 1. So another way that you could write 6/4 would be as 1 and then an extra 2/4 left over, right? Because you could take out that 4/4 from there and turn it into 1, and then you would have 2/4 pieces left over. So you could also look at that as like, this would be 4/4, which would be 1 whole, right? This would be 4/4, which would be a whole. And then these two pieces left over would be an extra 2/4, which we can see right there. So then all together you would have 1 and then 2/4. And that's something that we really aren't getting to yet. I just kind of wanted to show you that concept because we will be getting to that soon. And that's called converting an improper fraction to a mixed number. So an improper fraction is one that has a larger number on top than it does on the bottom. So it has a larger numerator than it does a denominator. So when we change those to mixed numbers like 1 and 2/4, that's called converting to an improper fraction to a mixed number. So that's something that you don't really have to do for this problem set today, but it is something I wanted to introduce to you. But ultimately for this problem set, if I was asking you to add 5/4 plus 1/4, all you would need to put would be 6/4. Okay? It would be awesome if you wanted to write 1 and 2/4, but you don't have to. It's not required. You can just leave it as 6/4. All right, so the next thing I wanted to show you is how we can look at a number line to add fractions like this. So if we are starting with 1/7 and then we're adding 3/7 to that, let's first of all just color in our little 1/7 part here. So we've got 1/7 right here. And then it says we're going to add 3 more sevenths. So let's do that. There's 1 more seventh, 2 more sevenths, 3 more sevenths. Okay? So if we were going to add 1/7 plus 3/7, that's how it would look on a number line. And then that would give us a total of what? 4/7, because we can see all of this together would be 4/7. All right, guys, I'm going to show you guys one more example here of adding on a number line. This time we're going to be adding 3/4 plus 2/4. So in this way, you're going to be kind of going beyond 1 and getting to a number larger than 1 whole after you add them together. So the first thing I want to show you is just if we add, one sec. If we start with 3/4 right here, this is what we're starting with, is 3/4. And then it says we're going to add 2/4 more. So then I'm going to highlight 2 more fourths right here. 2 more fourths. And now we can see that we have a total, right here, we can see that we have a total of 5/4. Or if you think of it like this, if we look at the top, we can see that 5/4 would be the same as 1 and 1/4. Because if we kind of counted this way on the top, we could think of it as this. It'd still be 1/4 here, still be 2/4 here, still be 3/4 here, but then I'm writing it as 1. I'm writing this next one right here as 1 and 1/4. I'm going to write the next one here as 1 and 2/4. I'm going to write the next one as 1 and 3/4, and then I get to 2, which is the same as 8/4. So again, it's kind of that concept of converting to mixed numbers and writing fractions properly, which is not something that we technically have to learn yet, but I think it's good to go ahead and start understanding that concept a little bit because it's going to be something that's important for you to understand very soon. So anyway, the answer to this problem could be either 5/4 if you just wanted to stick with the simple way of, leaving your answer, or you could also write your answer as 1 and 1/4. Because again, 4/4 would be the whole, and then you would have an extra 1/4 left over. So then you would end up with 1 and 1/4. All right, so the only other thing I wanted to show you is that you can add 2 fractions that have the same denominator without a number line or without squares. You don't have to have either of those things. So I just wanted to show you that real quick so you don't think you have to draw all that stuff to be able to add these. As long as you are adding 2 things that have the same denominator, so for example, like if they both have a 4 on the bottom, or if they both have a 6 on the bottom, or if they both have an 8 on the bottom, you are good to go. You can add them together, okay? So let's practice a couple problems here. Let's try 3/8 plus 2/8. And then we'll try 2/4 plus 1/4. And then we'll try 7/6 plus 5/6. So 3/8 plus 2/8 is going to be, well, 3 plus 2 is 5. We do not add the bottoms together. We just leave the 8 there because remember, we're just talking about adding 1/8 pieces together. So we're talking about, we have 5 1/8 pieces, so that's just going to be 5/8. Same thing here. We're going to be talking about having 2 plus 1, so that would be 2 1/4 pieces plus 1 1/4 piece. So that's going to be 3 1/4 pieces, or 3/4. Down here, we're going to be talking about adding 7 1/6 pieces plus 5 1/6 pieces, and that's going to give us a total of 12 1/6 pieces, or 12/6. And if you notice, 12 divided by 6 is 2. We could also write this as an answer of 2. All right, that's it, guys.